Hello guys. Let's quickly treat. Good day, guys. My name is Tutor Bello. Let's quickly treat radius of gyration and parallel axis theory. Now, the the movement of inertia of a body, of all rotating body, do we get the movement of inertia of all? Please let me check the video. Okay. The moment of inertia of all rotating body is related to its radius of gyration by I equals to what? Mk squared, where k is the what? Radius of what? Gyration. Where k is the radius of gyration. The moment of inertia of all rotating bodies is related to its radius of gyration by I, which is the moment of inertia, equals to what? Mk squared. So k is equal to this. And take note, radius of gyration varies depending on the body you are taking cognizance of. For instance, let's use uniform circular disc for an example. For a uniform circular disc that is rotating about an axis from its center, if the axis is at the center, we all know that moment of inertia is what? 1 over 2. We are even talking of uniform circular disc. Normally, the axis is at the center already. The axis is at the center. So we are not talking of meter rule. For meter rule, the axis of rotation could be at the center, could be at one end. We get that. So for uniform, since it's circular case, so the axis is at the center. 1 over 2 what? Mr squared. So since I is this, I is also this. So let's equate the two together. Mk squared equals 1 over 2 Mr squared. Since there is m on both sides, they can cancel out. So you have k squared equals 1 over 2 r squared. Take the root of both sides. So here we have square cancel this. We have k equals to root 1 over 2 times what? Root r squared. So k equals to what? Root 1 over 2 r. This r is not inside the root. This square will cancel this r. Let me see whether the video is. Yeah, please do we get that? So k equals to this k is the radius of gyration of this uniform circular disc. Radius of gyration of the uniform circular disc. So if I'm to find the radius of gyration, or if I'm to derive the formula for the radius of gyration of a beam or of a long ruler that is rotating about its axis, maybe from the center, this formula will be different. Take note of that. So don't just cram on and say, okay, radius of gyration is this. It depends on the object they are giving to you, and it depends on the axis of rotation. We get. So that's that for that. And radius of gyration tells us how far from the axis, that is axis of rotation, how far from the axis a mass effectively behave as if as if concentrated. How far from the axis the mass effectively behave. That's what radius of gyration tells us about. So please just take note of that. So we are not wasting much time on that. Like I said, it depends on object. Let's say a uniform um a thin rod that is rotating about its center. I equals 1 over 12 ml square. I think I'm right about that. And I equals what? Mk square, where k is the radius of gyration. So mk square equals 1 over 12 ml square. So m cancel m. We have root k square equals to root 1 over 12 times root what? L square. So this one cancel this. We have k equals to what? Root 1 over 12 L. So earlier we got root 1 over 2 R. That's for uniform circular disc. This is for a thin rod that is rotating about its center. So the radius of gyration of that thin rod is this. So take note of that. Now let's move to parallel axis theory. Now take note. There is something I want to explain. Sorry? Yeah, there is something I want to explain. Very important. Very, very important. Now, know that when we are talking of moment of inertia is telling us how hard, or how easy, let me say how hard it is to rotate a body. How hard it is to rotate a body. Do we get that? That's what moment of inertia is telling us. How hard it is to rotate a body. Now let's say this is a meter rule, this is the center. the moment of inertia of this meter rule that is um that is rotating about this axis which is at the center, as we all know that I equals to 1 over 12 ml, is it ml square or ml cube? I think I will have to prove the formula again, the one I did earlier. Is it square or cube? Sorry, should it be square or cube? I'm trying to check. Okay, I think it should be square. Whether square or cube, I will drop it on the comment section. I can't remember all that. So now I equals to 1 over 12, but this 1 over 12, 1 over 12 ml square for moment of inertia of a thin rod that is rotating about its center as its axis. Now, if we now have, if we shift the axis of rotation to a particular point that is parallel to that initial axis, that's why we say parallel axis theorem. This theorem only works when the new axis of rotation is parallel to the initial axis. It only works, this theorem only works when the new axis of rotation is parallel to the initial axis. Maybe as I'm rotating this thin rod about the center, okay, and I decide to shift the axis to another point different from the center, but that is parallel to that center. The moment of inertia, now the minimum, listen, the minimum moment of inertia you can ever get, it is when such body is being rotated about its center. Whenever you are rotating a body about its center of gravity, that's the least moment of inertia you can get. Why? Because the masses are distributed equally. It's at the center. The masses on this side equals to masses on this side. Do we get? So because you are picking your axis, your point of axis at the center of that object. But when you move your center of axis, when you move your axis from the center to another point, the moment of inertia increase. Why? Because more mass is being deviated to one end than the other end. So it won't be easy to rotate such body. I hope you get the logic. If I hold this ruler from this point, this thin rod, I want to rotate it, it will be easy because there is more mass on this part than this part. So it will be more difficult for me to rotate it than when it's at the center. Do we get it? So there's going to be an increase in moment of inertia the moment you shifted your axis from the center to another point that is parallel to the center. Now that increase in moment of inertia is known as what? Mh squared. That increase, that change is this guy. So now the moment of inertia about the new point I is going to give us the moment of inertia about the center. Let's call the one about the center Ig plus mh squared. I hope this thing is clear. Please, I'm done. Let me check the video. Yeah. The moment of inertia about that, because it's going to increase. This is the one at the center. The minimum, and please take note of that theoretical aspect. The minimum moment of inertia is when the axis is at the center of that body, which is this. The moment you shift the axis from the center, there's going to be an increase, whether to this side or this side. So for parallel axis theorem, when the new point is parallel to the center, so the moment of inertia about that new point equals to the moment of inertia about the center plus the increase. That's just it. Do we get that? So this is the formula where I is the moment of inertia or moment of rotational inertia about a particular point that is parallel to the center. Ig is the moment of inertia about the center. While this is the what? This is the increase. And if you are taking thin rod as an example that is rotated about its center, of which axis is about the center, this is the thin rod. I know that means our I equals to, now for Ig, rotation about the center of a thin rod, this is the formula, 1 over 12 ml squared plus what? Oh, I think it's squared. Yeah, plus what? Mh what? Mh squared. So we use the parallel axis theorem to know the moment of inertia about new axis that is parallel to initial axis that is at the center. I hope that's clear enough. Yeah, good. Yeah. Parallel axis theorem. That is why it is. This must be parallel to this. Please take note of that. And what of h? What's h? H is the distance between, we said this point must be parallel to this, right? But h is the distance or the perpendicular distance between this, now, and h is the distance between the center and the nail point. Do we get that? I'm trying to give us something. Yeah, there is something I wanted to say. You know, let me show us something because I just mentioned something now so that it can be clear. Now, I mentioned perpendicular distance, and here we are talking of parallel. For you to understand very well, let me clean it and show you. Let's say this is the axis, the center, this part. Do we get? This is the part. This is the axis about the center. This is the new axis. I know this new axis is parallel to the center. I'm using line now so that I can get why I call h perpendicular distance. Calling h perpendicular distance is not against parallel axis theorem. I said for parallel axis theorem, the new axis must be parallel. Are they parallel now? Of course, they are parallel. But they can never, let me not say they can never meet. Let's not go there. Yeah, if we enter real math, actually, two parallel lines, they are not line. The real definition is no line that can never meet. Though it's correct for your level. But two parallel line is lines that have equal slope. Their slope are the same thing. I think I'm correct about that. I think that's the real definition. But let's not go that. Let's not go that way. Though they can never meet, that's also true. So, but now, what's the distance between these two? H. Now, is the distance parallel to this point? No, the distance is perpendicular to this point. Do we get that now? So, parallel axis theorem is when the new axis is parallel to the center axis, but the distance between them is perpendicular to the center. So, h is the perpendicular distance between the new axis and the center of rotation, center of mass. So, that's that for that. Now, let's treat question now. Let's say I have few questions here. Calculate the rotational, which is same as moment of inertia. Let me, yeah. Okay, let me write it. Let me pause the video. I will write it so that we can grab. So, calculate the moment of inertia. Yeah. Calculate the moment of inertia of a meter stick with mass is 0.56 kg. Mass equals 0.56 kg. Whenever you are solving for this calculation, first bring out your parameters. About an axis perpendicular to the stick and located at the 20 centimeter mark, treat the stick as a what? As a thin rod. Let me check the question very well. Okay. Calculate the moment of inertia of a meter stick with mass is 0.5 kg about an axis perpendicular to the stick. Note, I'm trying to check this word perpendicular so that I can put it straight. About an axis perpendicular to the stick, not to the center, not to the, how can I put it down? That axis is perpendicular to the stick, not, we are talking of parallel axis, so that I'm trying to put it through so that when you see question, you know what it's talking about. That's why I said, let me check the question. I hope this is not parallel. Here now, we are not saying another thing different from being parallel. Now, this is the real meaning of this perpendicular to the stick. This is the stick. We are not saying it's perpendicular to the center axis. No. We are saying it's perpendicular to even the center axis itself is perpendicular to the stick. But this is the center axis now. Do we get? This is the stick. Do you get what you are saying now? The stick is like this. The perpendicular axis is like this, isn't it? So the center axis rather. Even the axis about the center is even perpendicular to the stick. So don't be confused. That new point is parallel. That new axis must be parallel to the axis at the center. But both of them are actually perpendicular to the stick. So don't be confused. You don't expect parallel here. So but yet that parallel axis theorem still valid. You know we said it only works when the new axis is parallel to the center axis. That's when it only works. But seeing perpendicular may be confusing. They say that means you cannot use parallel, you can use it because this is not, the question is not saying perpendicular to the center axis. It's saying perpendicular to the stick. And I've explained that. Now, located at the 20 centimeter mark. Now draw. I hope that's clear. So I'm trying to just tell you what is what. So now, let's say this stick is since you are not given, okay, they said a meter stick 100. If you are not given the length, since they mention meter, like meter, use 100 centimeters as the whole length. Now the mass 0.56 kg. Now we need to get h. Don't forget, h is the perpendicular distance between new axis. Let's say this is the center axis, this is the center, this is the new axis. Whether you put it on this side or on this side, there's no problem. This new axis can be on this side since they don't specify. They said located at the 20 centimeter mark. So the new axis is located at the what? Okay, let me just draw it and make it. The new axis is located at the what? 20 centimeter mark. Now we need the perpendicular distance between the new axis and the center. Now since this is a meter rule, the whole length is what? 100 centimeter. That means half is 50 centimeter. The remaining half is also what? 50 centimeter. Now, if this whole place, let me check the video, please. Okay. It's clear, yeah. If this whole place is 50 centimeter and this part is 20, then what will be our h? Our h will be what? 50 centimeter minus what? 20 centimeter. Your h is not the 20 centimeter. The 20 centimeter is the position of your new axis to one end of the meter rule. So your h now is the distance between the center axis and the new axis. So since this place is 20, subtract 20 from 50, then your h is 30, which is what? 30 centimeter. I hope this is very clear. Wow, yeah, I think it's very much clear. Now our solution now, we have to calculate the moment of inertia about an axis. That is about this axis. Right? There is a new axis. Do we get now? So our I is going to give us what? Ig plus what? Mh square. Convert this guy to meter. If you convert 30 to meter, that's what? 0.3 meter by dividing by 100. Is that clear? Now, this moment of inertia about an axis perpendicular to the stick, but they did not mention what I just want to mention now. But I just want to mention so that you can understand. That new axis is perpendicular to the stick, but parallel to the center axis. Once it is parallel to the center axis, then this parallel axis theorem can work. Do we get that? So now I equals what's Ig? Because this is a meter rule, a thin rod rather, a thin rod. We have to treat the meter stick as what? As a thin rod. You can see a thin rod rotating about its center. What's the formula? 1/12 ml square. Is it L square or L cube? I hope I'm not missing this formula. Maybe I will prove it before I stop to confirm whether it's L square or L cube. So I think it's L square. Yeah. We have m over L square. Yeah, it's L square. It's L square. Why am I even thinking it's cube? Don't mind me. Sorry. It's square. It's square. Everything is square, sir. I'm sorry. Pardon. Don't be annoyed. It's all this one that varies. Or this could be R. It could be L. It could be X. So it depends. And this guy too vary. Everything is square. M something square. M length square. Something like that. Don't mind me. 0.3 meter. So plus what? Plus mh square. Now this h square is the increase in inertia, increase in moment of inertia, because at the center we have the minimum inertia because the mass is distributed equally at both ends. But when this center shifts to this, when the center axis shifts to another point, the moment of inertia increases because there is more mass at one end. So for you to rotate the body, it will be difficult than when it's at the center. So the increase in inertia is this guy. So these two can never be equal except if there is no shift. This Ig cannot be equal to this except F. It can only be equal if the new axis is still at that same point, which is at the center. But it can no longer be equal because the moment of inertia is going to increase because you've shifted the axis. So this is the increase. I hope you get that. That is character. So here we have I equals to 1 over 12. What's our mass? Times 0.56. That's our mass. L, what's the L? The L is the this L we are talking about is the distance from the this formula is when the thin rod is rotating about its center. So this L here, our L is 50 centimeter, is like half of the distance of the whole meter rule. So our L is different from H. H is the perpendicular distance between the new axis and the center. So 50 centimeter is same as 0.5 meter. So our L here, let me solve it here. So here we have I equals to 1 over 12 times 0.56 times 0.5 square L square plus m 0.56 times h square 0.3 square. I hope that's clear. So this guy give us 1 over 12 times 0.56 times 0.5 square, that is 0.25 plus 0.56 times 0.09. Yeah, I hope I'm right. Yeah. So 0.56 is common to both, bring it out. 0.56 into what? 1 over 12 times 0.25 plus 0.09. So this gives us 0.56 multiplied by 0.25. I don't have calculator, so you can press your calculator and finish it. So equals to 0.56 multiplied by 1 over 12 times 0.25 is same thing as 1 over 4 plus 0.09. Can you get that? So here we are equals to 0.56 into 1 over 12 times 4. 12 times 4 is same thing as 48 plus 0.09. Let me write it as what? 0.09. I'm coming. So that's 9 times 10 raised by minus 2. So that's 9 over 100. Let me write it as what? 9 over what? 100. Now, I don't want to write like that. So we have so I should approximate it to 0.1. Yeah. Let me approximate it to 0. Use your calculator and finish the rest. 0.09, I want to approximate it to 0.1. We are already done. I'm done with my explanation. 0.56. 0.1 is same as 1 over 10. They are not equal, but they are approximately equal. Now, what was the LCM? Let's say the LCM is what? 480. 48 and 480, 10 plus what? 48 equals to 0.56 multiplied by what? 58 divided by what? 480. So what is the unit? I think the unit will give us, this is our final answer. Use calculator and finish it. But this is not 1 over 10, but it's approximately equal to it. So our I about the new axis equals to 0.56 multiplied by 58 over 480 kg meter square. Yeah. So that's that for that. Thanks for watching. Don't forget to like and subscribe. And please, I have a channel membership. You can just click the button below that says join. There's a button below the video. It says join. You can join. It's just 1K per month. Whereby we have our intensive class. It has been wonderful. My name is Peter Bello once again. Don't forget to like and subscribe. And please share the video. Help us to promote this channel. If this channel is really helping you, share the video. Thank you very much. And always comment whether the video is bad or is good, whether you enjoy it or you understand or you don't. Please drop your comment always. Thank you.